Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom.
Hide the planet! Hide the planet! Shut up again!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're doing HackerFrogs co-working today. So we're going to be doing some co-working. You're free to hang out and chat and, well, maybe get some work done. In the meantime, I'm going to be teaching myself how to do some C programming, learning C programming with this website over here called EduB. And we've been working through this course for maybe a month or so now. Anyways, Tattletale, hey, nice to see you here. You don't need to announce your departure. This is not an airport. And please stop sending strange messages in the chat. Thank you. All right, so what are we going to be doing today? So we're going to be working on some C language. We're going to be hanging out. We're going to be doing some co-working. Let's see. So we're going to be working on this for about 3 hours or so before we call it quits. Let me go ahead and put some time up on the clock over here. And we'll get started. Okay, so what are we doing here? So initiator is a simple way to set an array. Yes, you can initiate arrays. You know what? While we're doing our co-working, I might as well put on some music to make it a little bit less drab. Let's go ahead and put that stuff on. All right, turn it down a bit. Okay, so we're talking about arrays, and I guess we're talking about loops and stuff like that. All sorts of fun. This is super exciting. Well, the excitement is what you get out of it. But nice to see you here, Persona Management. Okay, yes, you can initiate arrays. That is, assign initial values to them at the time of declaration. So we can do this slightly differently than when initiating scalars because we want to specify more than one value. The syntax of an array, to be precise a vector initiator, is quite simple. So imagine you want to create an array where the value of any element is equal to its index. The value of any element is equal to its index. A suitable initiator would be as follows. So int vector, so this is an array with 5 elements, so it's equal to 0, 1, 2, 3, 4, so these are all integer contents. Okay, as you can see, the vector initiator is simply a list of values enclosed inside of curly braces. If you provide fewer values than the size of an array, like this, nothing bad will happen. The compiler determines that those elements that you did not specify any value for should be set to 0. Okay, so if we set our vector to a 5 object array and we fail to set the other 3 objects, they'll be set to 0. Good. Okay, and if you provide more elements than can be stored in an array like this, you'll get an error. So if we've got an array with 5 objects, but we set, how many is this? 6, then you get an error. So some old compilers can notify you without stopping compilation. This is called a compilation warning. It's a good habit to treat warnings with the attention that they deserve. So one more example, take a look at this. So int vector, and when we don't specify the number of objects. So we haven't specified the size of the array, but we have provided an initiator. So this is legal and will force the compiler to assume that the size of the array is the same as the length of the initiator. The vector array will be considered declared in the following way. Sir Night Night says it would be int 5 0 1 2 0 0. I assume that's the way that would go, but I'm not completely sure. But we can play around with it when we come to the coding examples. So the vector array will be considered and declared in the following way. So vector 7 0 1 2 3 4 5 6. So this is 7 objects because we start counting at the we start counting from the number 0. Okay, so we got a little lab over here. So familiarize the student with fixing errors in a program, integer numbers, printing on screen. So check the program in the editor. Find all possible compilation errors and logic errors. Fix them. Your version of the program must print the same results as the expected output. Before you use the compiler, try to find the errors only by manual code analysis. So our expected output when we run the program is going to be... how many zeros is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 zeros, 2 ones, 5 ones, 2 ones, and then 2, 3, 5, 8. Okay, so what happens when we run the program? Okay, so it looks like we got some errors. So we got line 17. Printf p ones. Note each undeclared identifier is reported only once. Undeclared identifier. Okay, so this is making reference to the ones array. So for I equals 0, I less than 4, what is the word? Increments? I increments. Printf p ones x. Ones x. So what is the ones array set to? So the ones array is set to nothing. Okay, ones I. Should it be ones I? Maybe. So this is set to, so the ones array is set to 1 and then nothing. 1 and then nothing. Well, I mean, I guess we could do it like this. So just set the first object in the array. I thought all the work was at the top. Well, okay. So I mean, it should work out like this. The thing is that there's only one object in the array. So Onyx, hello, nice to see you here. Is this C? Yeah, this is C. We're trying to figure out how to work with arrays over here. Okay, so this was on line 17. So for I equals 0, I less than 4, I increments. Print p ones. So what is p again? I need to figure out what %p is in. %p in C language. Is it like paragraph or is it like format specifier? It's a pointer. Okay. All right, so this should be printing out memory pointers. So we'll reset this. We'll run it again. Same thing. So each undeclared identifier is reported only once for the function it appears in. Okay, so they want this to print out like 5 times. 4 times? Int ones, yeah, maybe. So we don't want x in this case. We probably just want I. So I equals 0 because that's the iterator. So if we reset this and run it again, then we're getting a different thing. Okay. So now we've got line 8, Fibonacci sequence. So excess elements in array initializer and Fibonacci sequence 6. So Fibonacci sequence 6, we've got 7 objects. 1, 2, 3, 4, 5, 6, 7. So we just need to remove this extra object. And we'll keep on debugging. Okay, so we still have line 17. Line 17. So on line 17, what's the error here? Warning format P expects arguments of type void. Type void. So we probably don't want to print out like pointers in this case. We probably want to probably want to print out, so it's like 0, 1, 2, 3, 4. Ones. So ones, we're printing out numbers, so that's going to be decimal. Ones print out decimal, and I guess ones, we can fill this out. So ones is just all ones. 5 ones. Okay, and we will run it again. Okay, so we've got one more error here. So this is going to be on line 22. Line 22. So error, expected expression before something token. Expression before something token, super ones. So we're printing out E. What is E again? Is E like... Hold on. So we know what the P is. What is the E? So it's a floating point number, so a float or a double. Oh, okay, so we're not dealing with floating point numbers in this case. So we need to change that out. So it's not E we're printing out whole numbers, so just decimals. So D. Okay, and we'll try printing out. And thank you very much for the resubscription on Twitch. On Tier 1, thank you very much. 7 months, woot. Thank you very much, SOS Master. Let's give you a fun video redeem. How about some Jurassic Park just for you? Actually, what haven't we done in a while? How about all the things? Drink all the booze and hack all the things.
This one's dedicated to all the hackers. Yo.
Okay, so what are we printing out here? So for I equals 0, I less than 5, I increments, print out super ones. So super ones, it has to be I in this case, otherwise nothing's going to print out. Okay, hack all the things I feed. Indeed, yeah. Okay, are we getting what we want? No. We get another error, so this is on line 27. Line 27, warning ISO C does not support the Q GNU print. Ah, okay. So I mean, I think we just need to change these all to D's because we're all dealing with integers in this case. Okay, so we don't get exactly what we wanted here. We get pretty close though. So let's see, the last print statement prints out the Fibonacci sequence in the correct order, but the second to last print statement doesn't quite work. So this is supposed to be super ones, and these are all supposed to be 1, but it's 1, 0, 0, 0. Let's take a look at super ones. So super ones is, well, we need to fill this out. Okay, so it's 5 ones. And then the previous one, we've got too many. We've got too many ones. So in this case, we'll go 1, 1. And we need to change out the code down at the bottom there. So ones is only supposed to go twice. So we can correct the code. What happened in the first line? So the first line, apparently there's some undeclared variables or something, so it all went kind of weird. Let's take a look at that. So the first print statement uses zeros. So it's supposed to be 10 zeros. And what are we printing out? So let's double check. So 3, 6, so this is 10 zeros. What happened here? So because we've got 1, 0 here, all of the other elements of the array should have been... They should have been assigned 0. So I equals 0, I less than 15, I iterates. Oh, okay. Yeah, it's because there are too many, we iterate too many times. So this should be less than 10. Actually, less than 9? Because we only want 10. So I equals 0, I less than 9. This prints out 10 times. So this should be good. Okay, we'll run it again. Oh. Okay, we've got 1 too few. 1, 2, 3. 1, 2, 3. 1. Okay. We got too few in 2 places. So it should be less than 2 and less than 10, respectively. The whole counting from 0 thing. Yup. Okay, now do we have the correct output? This is the correct output. So we've got 10 zeros, 2 2s, and then 5 2s, and then the Fibonacci sequence, which is 6 numbers. Okay, great. Randall Stokes, hello, nice to see you here. Welcome to the stream. Okay, we'll move on to the next exercise. Not only ints. Okay, so far we've discussed vectors whose elements are of type integer only. Don't be misled. You can use arrays of any other type. For example, this is an array in which you can store 10 floating point numbers. So float array 10, and you can store 20 characters here. You can store 20 characters here. Okay, the latter array will, however, be treated a little bit differently by the compiler. Its initiator will be different too. This is why we prefer to discuss it later when we begin the chapter on strings. So we've got an array of characters. So in this case, it's called surname. It's got 20 characters. Then we got this other array over here called the float array. Seems pretty straightforward. Randolph says, strange, you didn't get a warning from printing past the end of the array. Hello. Yeah, I mean, it really depends on the compiler. Some compilers, it seems like there's a lot of differences between compilers in C. Henki, hello, nice to see you here. Good morning from UTC +7. And yeah, good morning. Hope you're having a good one. Okay, so arrays, printing integers, printing on screen. So write a program that asks the user to provide 4 names and prints them in reverse order. For now, assume that each name consists of a maximum of 20 letters. So 20 letters, sure. Because you don't know about multi-dimensional arrays, use 4 variables. Later, you should store this kind of data in a 2D array, or a more advanced data type. Okay, your version of the program must print the same result as the expected output. So sample input, Emma, Olivia, Noah, Liam. So we're just printing out the elements of the array. Okay, write a program that asks the user to provide 4 names. So I guess we can... So, let's see. Character array. Name 1. It's going to be a maximum of 20. And we initialize it. Well, we don't need it to be initialized. So we don't need to do anything here. So we can do 4 names. So name 1, name 2, name 3, and name 4. Okay, so as Master says, there are flags that can enable more checks or less checks. Randolph Stokes says, reverse order means the last name inputs prints first. Reverse order meaning last name input prints first. Oh, no. They mean that the print the 4th one first, and then the 3rd one, then the 2nd one, then the 3rd one. I think that's what they mean, because if we take a look at the sample input, Emma, Olivia, Noah, Liam, then they print Liam first, and then Noah, and then Olivia, then Emma. So it's just printing them out in reverse order from the declarations, I guess. Okay, CipherLogic says, wouldn't it be better to do it by IDX rather than 3 separate character values? IDX. I mean, I don't think I've learned IDX at this point. I guess they'll teach us that later. Okay, so we've declared our character arrays, and then we'll take in the input. So we can do puts, and then like enter the first name. So puts is gonna take in a character array. C for characters, right? Index of the array. So this is gonna be no. This is puts. I was thinking of scanf for some reason. Okay, so we do puts and scanf. So puts is going to be enter the first name. And then scanf is going to save it out to... It's going to save the characters to first name, or name 1. Like this. And then we'll repeat this 4 times. With second name and third name, etc. Okay, name 1, name 2, name 3, name 4. Well, okay. So after that, all of the names should be recorded, and then we'll do a little for loop that prints out the stuff. Is this StarCraft music, or am I tripping? Yeah, this is StarCraft music. Flix IDK, hello, nice to see you here. Okay, so we'll do like for loops, for something something, and then like a little loop. So the loop is just going to do puts, no, printf. Printf the character from name 4, name 4I, and it's going to be why can't it be both? Okay, CipherLogic says you could have instantiated the array with a length of 4 and then iterated the array and then do the put and then iterated the array and then do the put and scanf inside the loop. And Imperio Austro Hungaru, hello, nice to see you here. For loop, just print four printf statements. For the loop, just print 4 printf statements. Oh, well, So we're printing out the entire array, right? Imperio is easier. Thank you very much. Okay, so we want to print out the 4th one first. I mean, okay, we don't necessarily need to... We don't need to do a for loop, right? We just need to do printf, like for printf. So printf 4 times, and we're printing out characters. 1 through 4 if you're doing it this way. So printf, let's just do a test one, right? So just printf C and we're printing out the entire array. So name 1. And we'll just do name 1. And just hard code the names while you're at it. Well, I mean, we don't necessarily need to hard code the names because they're expecting input and output, right? Okay, so what's happening here? So format C expects arguments of type character. This is line 15. Name 3. Okay, so it's over and over again. Argument of type character, okay. Yeah, so we get this wording over and over again. So these are, I mean, these are supposed to be characters that we're recording here, unless I've got something wrong. I mean, C is character, isn't it? So C is... These are characters. Single characters, right. I wonder what's wrong with the scanf in this case. So we should be taking in characters, enter the first name, and assign it to name 1. Name 1, name 2, name 3, name 4. Okay, how about the initial variable like character 4 name 20? Character 4 name 20. You mean up here? So we're doing character array. Let me just refresh myself because I don't know if I've got the format correct. So C language character array. So character something something equals something something. Well, I mean, it should be okay if we just don't instantiate anything, right? Yeah, copy the full scanf line and put that into AI and ask why it doesn't work. I mean, I kind of want to figure out. Oh, that's a single character. So single character. Now, what are these types called again? So the percent C. Strings. So for strings, it should be S for strings. Okay, so this doesn't take in a single character, it takes in an entire string. Right. Okay, we'll try it again. So we're scanning not single characters, but strings. Okay, and we'll see if it works now. Run the thing. Expects an argument of character star. Scanf and name 1. Do I still have something wrong with my syntax? So puts enter the first name, scanf. Putting the and. Wait. Putting the and makes it a character. The and makes it a character? So we want to take in the scanf in the scanf input and then assign it to name 1. Remove the ampersand. I'm kind of confused. Isn't this the way we're supposed to be doing it? Makes it a pointer to a character. Oh. Okay. Seems I've got a lot to learn. Enter the first name. So the first name is, I don't know, Liam. Emma. Enter the second name, so we have to enter all the names. Olivia, Noah, Liam. Okay, and then we print out the last name. No ampersand in this case. Okay. Turkish Kaido, hello, nice to see you here. No pointer to a pointer to a character. Repetition was intentional. I need to... Yeah, I need to... This is why I'm taking the C course, to get better at using C. Okay, so their expected input... So put in Emma, Olivia, Noah, Liam, and then print out Liam, Noah, Olivia, blah, blah, blah. So, I mean, it's pretty easy. We just need to print out name 4 to name 1 in a succession of printf statements, and that works. So 4, 3, 2, 1. Mr. Maz says, C is Satan, not gonna lie. Don't worry about that now. You will get it after working with pointers. Mr. Maz says, Python Rust first, which I would have gone C. Okay. I mean, I'm working with C because I need to get better at doing binary exploitation and reverse engineering, which involves pseudo C code. Okay, enter the first name. Emma, Olivia, Noah, Liam. Okay, so it looks like I screwed up because we need to have line breaks at the end of all these. Okay, let's try it again. I would have gone C first. CipherLogic says Rust is gross. I haven't touched Rust at all. I don't know what Rust is like. Okay, so first name Emma, Olivia, Noah, Liam. Liam, Noah, Olivia, Emma. Okay, so we've got the correct output, so we can move on. Malloc is fun, not. Hanky Loudbook says, you spend a lot of time using multi-array, you're going to need a few lines. Nullsec says, I didn't mind Rust, honestly, but I think C is more important. RoboPimp says, Linus says Rust is acceptable. I mean, we all respect Linus, right? No tetanus shot needed then. Okay, so we're doing more coding here. So fixing errors in program, integer numbers printing on screen. Write a program that asks the user to enter 4 numbers as strings and creates a human-readable IP address from them. Your main task is to think about an appropriate data size to store the IP address. Appropriate data size to store the IP address. Okay? After this, your program should print the string. So to insert 4 numbers and 3 dots into a string, you may use the sprintf function, not described, copy all the characters manually, or use another method more suitable to you. So your version of the program must print the same result as the expected output. So if we put 1, 2, 3, 4, then the expected output for the IP address is 1.2.3.4. Nullsec says, I like his kernel, but he's a bit of a goober. A bit of a goober? I don't know. Let's see. Henke says, C is the mother of programming languages. Anarchist says, C is a pretty terrible language to learn for coding, but obviously useful for reversing. And Duck says, assembly. Yeah, I mean, we'd learn about x86 assembly. Well, I mean, you need to learn about the assembly language that you're working with. So if you're dealing with x86 devices, then it's going to be x86. If it's ARM, it's ARM. Learn the language of the device that you're working with. Okay, so asks for 4 numbers as strings. I mean, my instinct is to just, like, you know, integer first, integer second, integer third, integer fourth. And then do like a scanf, or like puts and then scanf. Puts, enter the first number, and then second number, third number, fourth number. Okay, so why are we talking about Fortran again? Oh, the Fortran is the mother of programming languages. So COBOL, I mean, I don't know if I'm going to be working with COBOL. SysOS says, Torvalds knows what he is. I called his concurrent versioning system Git for a reason. Punch cards. CypherLogic says, I actually do code COBOL a few times a year. A few times a year? I mean, for what reason, CypherLogic? Binary. I guess binary is kind of like the... Binary's not really a programming language, though. Okay, so we got second number... Oh, sorry. Third number, second number. And then we'll do our scanf. So we're assigning these numbers, right? So in this case, we are going to be doing %d and then doing a pointer to first. And then second, third, and fourth. Okay, CypherLogic says I work on PeopleSoft, HRMS, and FSCM systems. I don't know what those acronyms stand for. Can you help me out? Okay, and just for fun, we'll just print out the first variable here. So print out something like, this is the first number okay, we'll give it a try. Oh, are we? Okay, okay. So this is another case where we need to... We're not really assigning it. We're not putting it into the pointer. All right. Expected before return. Oh. Always end your statements with a semicolon. Expected before first, scanf D first. Expected, okay, this is line 11. Oh, yeah. We need to put in a comma here. Okay, CypherLogic says human resource management and financial supply chain management. Oh, okay. So this is... It's a lot of COBOL on micro focus servers. Okay, now we've got... line 11. So now we've got line 18. Print O. I'm just full of typos today. Turker Kaido says, if one of you guys could explain what the scan S means. I barely know C#, and that's not... So scan F is basically taking in user input. So it takes in user input of a certain data type, and then it assigns it to some variable. So scanf is basically a function that takes in user input. Okay, enter the first number, 255. Enter the second number, 255. 255 and 255. The first number is 255. Okay, so it's like user input. Yeah. So it takes in user input and it records it somewhere. So scanf takes in user input in some sort of data type. So in this case, it's going to be an integer, and then it gets assigned to the fourth variable. Okay, so the printf statement that we're doing here is supposed to be 1, 2, 3, 4, or 1 dot. Seems easy enough. So that would be something like %d, 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 and then we put a dot in between each one of those. So it's going to be first, second, third, fourth, like this. Pointers are great if you hate people. I hate people. I hate pointers. Pointers are great if you hate people. Okay, SysOS says scanf is the inverse of printf. It defines how to parse some data from a FD source, so file descriptor. And for pure scanf, it's standard in, but all the flavors like print. Yeah. So let's see if the program works like this. So take in all the input. So first number 255, 255, 255, 255. So it does come out as expected, but it said like to insert 4 numbers and 3 dots into a string, you may use the sprintf function. Copy all the characters manually or use another method more suitable to you. I mean, printf works okay, but I wonder why they talk about sprintf. So they're also asking us to think about an appropriate data size to store the IP address. So to store the IP address, maybe we're talking about, what was it again? So it's like long and short, right? So C language long numbers or long integers. Short integer. Okay, a short integer declared using short or short int. Data type used to store small whole numbers while optimizing memory usage. So it occupies at least 2 bytes in memory. So I mean, I guess we're supposed to be using shorts in this case because we're only dealing with numbers from 0 to 255. Unsigned characters. Yeah, I guess we're also dealing with unsigned characters. CypherLogic says, what is the end goal on this learning path? Like the ultimate goal. If that was stated, I'm sorry if I missed it. Yeah, so why are we learning C? So we're concerned with learning cybersecurity CTF exercises. And a couple of major categories of cybersecurity CTF exercises are binary exploitation and reverse engineering. So for binary exploitation, most of the easy level, well, most of the beginner level challenges are written with insecure binaries written using C as source code. So most of the time we're talking about insecure implementations of C functions. So what are our classic insecure C functions? So puts, no wait, yeah, puts, there's scanf is an insecure function, and a couple of other ones, but puts and scanf are your classic insecure C functions. So that's part of binary exploitation, so we need to understand the programming language that the binaries are written in to better understand how to exploit them. So for reverse engineering, reversing tools decompile programs into pseudo C code. Pseudo, how do you spell pseudo? Pseudo C code. So it benefits people learning reverse engineering, or reversing, I guess, to learn C, so we can understand the decompiler output. Okay, Duck asks, what is puts? So puts is a simple function in C that just prints something out. But because puts doesn't check the size of memory, it can be insecure. Okay, example answer. I'm going to take down both Apple and Google brick by brick. Okay, so I mean, I guess the simple answer is I want to be able to solve quote-unquote simple binx and reversing CTF challenges in any event I take part in. Okay, I'm going to take down NSA for the people. I don't know if I'm going to say that on stream. Okay, so those are short-term goals. I mean, your personal endgame goal. The personal endgame goal, are you talking about the personal endgame goal for learning C, or the personal endgame goal for cybersecurity? I'm going to take down both Apple and Google brick. Don't quote me on that. The ultimate goal for cybersecurity. Where is all my education going to take me? So personally, all the education is going to take me to a place where I can be able to teach basic concepts to people and spread the word of tech and security. There you go. So I'm here to learn so that I can teach people. That'd be nice. Okay, I assume this is career-oriented. The people might want to know. I'm the people and I want to know? Sure. It's never about the destination, it's the friends. It's the friends we made along the way. Delusions of grandeur. I don't know about that. But anyways, I mean, my goal is to provide people with good education for the people who want to get it. And this is the type of thing that I really would have appreciated when I started learning about cybersecurity and getting into the industry. I just want to provide people with a good place to learn. Okay, but in the meantime, we got to teach ourselves how to interact with the technology and the programming languages. So this is why we're learning about short integers in C. Okay, so short or signed short, unsigned short is memory size 2 bytes or 16 bits. So it's 0 to this number. I guess unsigned short is what we want to use if we want to maximize our memory, right? Definitely about the journey and the ahas, that's what it's all about. So D is a decimal identifier. Yeah, when we're talking about the different... What are these called? So... Okay, so C language, what... I'm pretty sure I knew the name of it before. What is %C and I don't know, D? Data types? They're not necessarily data types. They're called format specifiers, right? So the exact name that we use for these things are format specifiers. And I guess we should probably learn about a bunch of the common ones. C format specifiers. So, for example, %D is decimal, basically talking about integers. Integers. Then got %F for floats. Floating point numbers. How many bits are stored in memory, essentially? So, let's see, unsigned characters would be more efficient for IP. Yeah, definitely. So the %C is for single characters. So character data types, and %S is for strings. Character arrays. And then we've got %P for pointers. So these are memory addresses. And then there's a lot of different ones, but I guess we should be aware of all the common ones. Data types are different. So if we're talking about like C data types, we've got integers, floats, characters, arrays. These are our basic ones, right? Integers, floats, characters, and arrays. And am I missing any of them? Wasn't E also a float? Yeah, so it was a different type of float though. There was also like long integers, or like I guess when we're talking about like the difference between different types of floating point numbers, I guess it's talking about precision, right? Another float type. Cypher Logic says, ever tried to create a buffer overflow? Yeah, we've covered buffer overflows on the channel before, especially when we're talking about like CTF challenges. So stuff from like Pico CTF, which is now Scilab Academy. Booleans. I don't know if Boolean is a type in C. Is Boolean a type, data type in C? Boolean is a data type in C, but it was not part of the original language. Oh. Huh. For some reason I thought that you had to code in booleans. Nullsec says buffer overflows used to be part of OSCP training. I think they moved away from it. Yeah, you no longer have to learn buffer overflows as part of the OSCP training. But it was a fun part of the training though. Boolean values. Wait, is Boolean like is Boolean a format specifier then? Okay. Use %d for 1 and 0. Should have pointers in there, and arrays aren't really a data type. You can't really cast to an array type. So pointers... I mean, this is why we're learning. Pointers are a character type. I guess arrays are not a data type. So pointers, in this case, pointers are memory values or memory addresses. Let's continue. Okay, CipherLogic says, I think buffer overflow should be required as an early exercise, helps you understand what's happening with the memory. Nullsec says, I hate the term casting. Casting makes C seem like voodoo. I mean, a lot of people think that, you know, programming is kind of like magic, right? Ah, okay, we got pointers. We've arrived. And we've got a little ad running on Twitch right now, so I'm just gonna put on the birds. So when we've got a little break, I need to take a little bit of water. I put on these lovely guys, which are in my backyard. So I'll be back in about 60 seconds, but enjoy the birds, and I'll see you in a bit. So these are my favorite birds in my backyard. These are Steller's jays. They're kind of like the West Coast version of the blue jay. And they come and they eat all of the peanuts and the seeds in the bird feeder. Then they go away. And that's what they are supposed to do. Okay, so Turkish Kaido, you're talking about like casting, right? So casting in programming languages. So casting is basically treating one data type like another data type. So if you've got an integer, integers can be cast into floats, so floating point number. So for example, like the number 1 cast into a float is 1.0. So your integer value turns into another type of data. So you can also do like strings. So the integer can be cast into a character. So the character, which is treated differently. Okay, Turkish Kaido, Shy Hat, is this live? Is this live? I mean, if I wasn't live, I wouldn't be able to respond to your questions, Turkish Kaido. Linux developer, hello, nice to see you here. If only Het was online. Het Tanis? I don't think I've really caught very many of Het Tanis' streams. He might stream at What time does he usually stream? We're talking about another live streamer who does a lot of Linux stuff. This is an amazing pre-recorded, yeah. Okay, so what are these pointers? So pointers are also values, but they're different from those that we've operated with so far. The types which we've used are closely linked to computer data processing, but have reflected our ideas and our intuition. All of us use integers in everyday life to count all countable things. We use floats when we pay for something and characters when we arrange an alphabetical list of guests at a family celebration. Pointers have no simple analogy to our daily lives, and their values are unreadable to humans and completely useless. Okay, Linux developer says I can shoot him a message on Discord about my first message. Your first message? What was that? If only Het was online? Do you think he would come online if you asked him to come online? Do you use Grafana? I'm not really sure what Grafana is. It sounds familiar. It's before that. Okay. So what was your I got Grafana working rootless via a quadlet file. Oh. Yeah, I don't know what Grafana is. Okay, I was asking about I meant the birds. Oh, the bird videos. The bird videos, they're pre-recorded. They're not live. It's nighttime where I am right now. So I basically take all the best footage from the security camera. Okay, computers, however, can make great use of pointers, giving developers powerful capabilities when designing algorithms and data structures. So be prepared for the fact that not everything will seem obvious at once. This is normal. They'll take some time before you accept the pointers themselves and their specific traits. You may remember that we've dealt with pointers some time ago when we used the scanf function. It was a very simple exercise, but now we're going to plunge into much more complicated issues. Linux developer says it's observability platform. What is Grafana? Open source data visualization and analytics platform used to query, visualize, and set alerts on metrics, logs, and traces. Oh, so it's kind of like I think I've heard of Grafana used in the context of security. So keeping track of logs and stuff like that. Zamru says, I remember when I was first learning C++, how much pointers threw me. Yeah, pointers are not super intuitive, and I'm going to try to understand pointers better by the end of this lesson. We'll see. That's one use case. Yeah, okay. I think I have heard of Grafana before, but I'm not super familiar with that. So modern computers have large, fast memories. You know that memory size is expressed in units called bytes, and you also know that when you declare any variable, for example, in such an obvious and simple way, the variable occupies a little piece of the computer memory. So far, all we need to know is what value is stored in the variable. From now on, we're also interested in where this value is stored. This trait of the data, to say it more formally, attribute, is often called the address. We all live at certain addresses, just like every variable lives at its address too. Try to see the important difference. The value of the variable is what the variable stores. The address of the variable is information about where this variable is placed, where it lives. Okay, Linux developer says it can track all kinds of data, even health data if you choose to do so. For example, your gaming watch, if you have one, that is. Okay. Turkish Keto says, I'm going to learn more C next stream if I remember. It's too late. No worries. If you have to go and do your daily life stuff, please don't let me get in the way of that. Okay, pointers are used to store information about the address of any other data. We can say that pointers are like signposts. They don't say anything about the place itself, but they show clearly how to reach it. So what we got here? C Institute is this way, sure. Okay, we'll move on. Oh, Garmin it's Garmin. It's a brand. Okay, I don't know about Garmin. Okay, creating a pointer. Let's start our new adventures with a simple declaration and an equally simple operation. We'll encounter a few new operators too. So int star p. So star p is pointer p. So this declaration sets up the variable named p, which isn't an int. The presence of an asterisk means that the p is a pointer and will be used to store information about the location of the data of type integer. Pointers are always used to point to specific data referred to in the declaration. The C language can use amorphous pointers too, which can be used to point to any data of any type, but we're going to discuss them at the very end of our story. What is the type of variable p? Well, I mean, variable p is an integer, right? So there are a few answers identical in meaning, but considerably different. First, we can say that p is a variable of the type pointer. Oh, it's not an integer, it's a pointer to int. Secondly, it could be thought as follows. P is a variable of type integer asterisk, where asterisk reads simply as asterisk. Assigning values. How can we assign a value to the pointer variable? Can we assign a value to the pointer? Of course we can. In the same way you can assign any value to any other variable by using the equals operator. A more important question is, which values are we allowed to assign to the pointers? Using a literal is not an option. The compiler will, of course, allow you to write something like this, but if you think that you know what's stored in the computer's memory at the address 148324, then you are clairvoyant and computer programming is just a waste of your time. Okay, so you're not supposed to use literals in your pointers. Null pointers. There's one distinctive exception. You can assign 0 to the pointer variable. Doing this doesn't prompt any questions from the compiler. So pointer equals 0. So a pointer which is assigned a value of 0 is called a null pointer. So as in Latin, nullus equals none. It doesn't point to anything. So it's like a signpost with all the writing removed. It still exists, but with no clear purpose to the traveler. Okay, let's turn down the volume a bit. That's not a null, it's a 0. Well, I mean, they call it a null pointer. Well, I mean, I guess null would just be the word null, right? Despite appearances, this pointer can be very useful and sometimes even necessary. Due to the fact that assigning a value of a 0 to a pointer variable sometimes causes misunderstandings and mistakes, some may confuse the pointer with a variable of the type int. There's an unwritten agreement that developers will avoid assigning null pointers. There's an unwritten agreement that developers will avoid assigning null pointers. Instead, they will follow this next convention. P equals null. The null symbol is actually equal to 0. It looks like a variable, but you cannot modify its value. It's called a macro. We'll tell you about it in Module 8 of this course. So the same convention also says that null should only be assigned to pointers. This is a matter of care and elegance with regard to the programming style. We have one caveat. If you want to use the null symbol, you have to include one of the following header files: stdio.h or stddef.h. The null symbol is defined there. So how do we assign any meaningful value other than null to a pointer? We may assign to a pointer a value which points to any already existing variable. So to do that, we need to use this ampersand operator called the reference operator. This is a unary prefix operator. The operator simply finds the address of its argument. See this statement. So P equals, what do we call this? Reference? Reference of I. So after completing the assignment, the P variable will point to the place where the I variable is stored in the memory. So this can be shown in the following way. So what's going on? So P points to I. Sure. P points to I. Okay, so if you assign null to the pointer, it looks like this. So P equals nothing. Okay. So from now on, the P pointer points to neither the I variable nor any other variable. We can use the following symbols to express this. As you can see, the P pointer is grounded. What we can do with the pointer that is not null, what can we do with the pointer that is not null and points to a value? We can dereference it. So dereferencing is an operation by which the pointer variable, as we'll see later, it's not only a variable but also an expression that yields a pointer, and becomes synonymous with the value that it points to. Look at how we declare a variable of the type integer ivar and a variable of type I asterisk ptr. We can do this with within a single statement as shown. So integer ivar and then pointer ptr. So these are two declarations at once, right? So the ivar integer and then also the pointer ptr. So let's assign a value of 2 to the ivar variable. Everything's clear so far, right? Okay, so ivar equals 2. Now we make the ptr pointer point to the ivar variable. So ptr equals reference of ivar. So how do we get a value pointed to by the pointer? We have to use a well-known operator, the asterisk, but in a completely new way, as a dereferencer. If you place an asterisk in front of a pointer, you get a value which is stored at the location pointed to by the pointer. So asterisk ptr is pointing to something. The following invocation will display 2 on the screen, as the printf's second argument is the dereferenced ptr value. Note ptr points to ivar and ivar is equal to 2. So print dereference of the ptr pointer. Okay, if you write a statement like this one here, ptr equals 4, you won't change the pointer value. You will instead change the value pointed to by the pointer. This is an important difference. So whatever this pointer is pointing to, the value of what it's pointing to will change to 4. Don't forget that if you declare a pointer in the following way, any type pointer, okay, it means that the pointer variable is of any type, and the pointer expression is of type any type. So notice the place the asterisk occupies in both cases. If you use void as any type, then you can create a valid pointer to some memory, but interpretation of pointed value belongs to you. We have to mention that you can typecast pointers, but it is, in many cases, bad practice. Think twice before you do this. Also, don't forget that dereferencing null pointers is strictly forbidden and leads to a runtime error, which stops your program's execution at once. Another new operator. So the operator we want to introduce now is distinguished by its appearance. The operators we've encountered so far have been coded as single characters or digraphs. This new operator looks like a variable. Don't be fooled. This is a unary prefix operator and with the highest possible priority. There's another difference too. A typical operator requires a value as an argument and usually changes the value in certain ways. The new operator expects that the argument is a literal or a variable, or an expression enclosed in parentheses, or the type name. This is the only C, or the type name. This is the only C operator which allows its argument to be a type. The operator provides information about how many bytes of memory its argument occupies, or may occupy. The name explains the purpose. Here it is, size of. There's no space between size and of. The size of is not only an operator, it's also a keyword. So variable I will be assigned a value of 1 because character values will always occupy 1 byte. Note that we can achieve the same effect by writing I equals size of character. Okay, so the number of bytes that character occupies, this is now I. You may not use parentheses when the argument is a literal or a value, but you must use them when the argument is a type. So integer I, character C, I equals size of C. You may not use parentheses when the argument is a literal or a value. Okay, so, but you must use them when the argument is a type. So I guess the argument is the character, size of C. So variable I will be set to a value of 10 because this is the number of bytes occupied by the entire tab array. So character tab. So it's a character array called tab, which is of size 10. So I equals size of tab. So the size of tab is 10 bytes. So I equals 10. Variable I will be set to the value of 1. Can you explain why? So size of tab first element, or element 1. So element 1 is just 1 byte because each one of the elements occupies 1 byte. The following example is not so obvious. So integer I equals size of I. Size of I. So values of the integer type occupy 32 bits. 32 bits, for example, 4 bytes in most modern compilers and computers, but we cannot guarantee that this is true in all cases. So size of I, so size of integer is usually 32 bits? Okay, so we're getting thrown into the pool. Analyze the program. It would probably be a good exercise for you to compile and run it on your computer. From this, you'll learn how your computer and compiler use the memory. The program isn't too tricky, but its role is to identify interesting features of your environment, and it's good enough for this purpose. Okay, time for an updated priority table. Study it carefully, it will come in handy very soon. So I have not been studying the priority table very much, because I'm assuming that the compiler is going to take care of it. But I guess we're going to have to need to know this when, when we start doing our tests and stuff. Oh, hello! Is it Vladimir? Hello, nice to see you here. We're just learning about C language right now. Okay, so what's going on in this program? Let me just copy the whole thing, and we'll go to some place where we can paste it in and take a look at it in a more comfortable environment. Okay, so printf, this computing environment uses bytes for characters, so size of characters, bytes for short, size of short integer, bytes for integers, size of... Okay, I mean, we can probably compile this in our own computer and give it a try. So all we need to do is... We'll make a test.c file, and we'll just paste this in. And I think this should compile even without like a header, right? Although maybe we should put in like includes standard IO stdio.h. Which IDE is this? Yeah, this is Nano. So, I mean, it's not really an IDE, it's just a text editor. I'm not really doing anything fancy with my code. So we can probably just gcc test.c, output to test, and then run test. Okay, so this computing environment uses 1 byte for characters, 2 bytes for shorts, 4 bytes for integers, 8 bytes for longs, 8 bytes for longs, 4 bytes for floats, 8 bytes for doubles, and 8 bytes for pointers. What's a Nano? Nano is it's a specific text editor for Linux. Okay, Nullsix says, I thought Shy just picked a random name for the Cyrillic characters for half a second there. Yeah, I mean, I did a little translation last time Vladimir showed up. Okay, so I guess you can use LSP in Nano too. LSP, Lisp. We're talking about the programming language. I use NeoVim, by the way. Okay, no worries, no worries. A lot of people are big fans of Vim and NeoVim. Boy says, I got accepted to college for electronics and computer engineering. I want to learn a lot of this low-level and hardware stuff. Yeah, I mean, C is very good for... C is very good to learn if you're dealing with hardware, because a lot of hardware stuff interacts with... I don't want to get this wrong, but I do hear that C is good for people who deal with hardware. Okay, so this is our computing environment, huh? Sounds good. LSP and Nano, language, syntax protocol, syntax highlighting. Oh, okay. That makes more sense. Thank you, Anarchist. Okay, so familiarize the student with pointers, the size of operator, fixing errors in a program. So write a simple program which prints the size of types in your architecture. Check this for all the basic types, variables of some types and some pointers, like the expected output list below. Your version of the program must print the same result as the expected output unless you're working in a different architecture. Okay, so... LSP as in language server protocol? Ah, okay. So syntax highlighting stuff, right? Okay, so I guess what we basically need is something that is very similar to the last program we ran. So standard H, int main, our code, return 0. So something like... I'll just use this as a template. Okay, so let's see. So we're supposed to print out 1 byte for characters, 1 byte for character variables, bytes for shorts. Okay. So I guess we can just do this as one big printf. Depraboy says, I did Java in high school. The hardest things in high school were stuff like binary trees and manipulating them. Now moving to C because I'm curious about the OS kernel stuff, compilers. Yeah. This is, I mean, one great thing about C is that the Linux kernel was written in C. So if you want to understand about how to write programs that interact with hardware, especially if you're dealing with a Linux environment, C could come in very handy. Okay, so print something byte for characters. Something byte for characters, size of character. Something byte for character variables. character variables. So what's the difference then between characters and character variables? I guess we need to define a character variable so that we can print out the size of it, right? So character var, and we can just leave it undeclared because the size of it doesn't really change. Okay, I think they mean like character C, print size of C. Oh, okay. Yeah, makes sense. Zamru, hello, nice to see you here. You commented earlier on in the chat, right? I'm sorry if I didn't say hi. Should be an array of characters. Should be an array of characters? I mean, the character variable should be sufficient, right? Because they're looking for one byte for character variables. And they're also looking for 2 bytes for shorts. So X number of bytes for shorts, so size of short integer. Shorts and short variables. I wonder if what the difference is really. Actually, wait. Sorry, because we're not using a type here. We're using a variable. We need to do the syntax like this. So some number of bytes for shorts, and then short variables. In this case, it would be, we'll call it like short var. Short integer, short var. Okay, so Depraboy says, in Java we had OOP, object-oriented programming, but in C, I've heard structs and pointers. Are they the same? Then how are they different? So I mean, I'm not really... So the thing about C is that we don't have object-oriented programming in the default C language. I'm not really too sure what structs are, but I guess I'll learn about it eventually if I keep on going through the course. But I think there's something from what I infer, like there's something similar to objects in structs in C. Anarchist says you can actually have parentheses there, and I think a bunch of people do, but the parentheses are part of the expression, so you're doing the size of the expression C, which is the same as size of C. Oh, okay. But it's just that the parentheses have to be here if it's a type that we're doing the size of, right? Although I guess, I mean, size of including it in the parentheses is more like what we would see in Python. So it really, I mean, it's more familiar to me. Size of short variable. Ints and int variable. Oh, this is a long program. I guess we need to define an int variable. Required for types, optional for expressions. Is that Python? No, we're dealing with C programming right now. Truther dead on. Hello, nice to see you here. Hope you're having a good night. Okay, so this is just going to be an integer variable. And then we do longs and long variables. Seems a bit redundant, but okay. Okay, did you ever try the integrity CTFs? I'm working on that at the moment. No, you know what? You know what's really funny is that oh, sorry, I got the names of some companies mixed up. I got Integrity and Ubiquity mixed up. But the latest Darknet Diaries episode over here is pretty good. And it talks about some... I guess, would it be right to call the person in this story like a software developer? I think he's more of like a data engineer or something, or like a system engineer. And he decided that he wasn't being appreciated enough at his job, even though he was making $250,000 a year. And he decided that he was going to extort his company out of like $2 million. But he gets caught when he tries to do his hacker thing, and now he's in prison. But it's an interesting story if you want to give it a listen. Sorry. So long integers, size of long variable. Okay, Anarchist says structs in C don't support inheritance, though you can kind of fake it. C++ has explicit object OO type support. Okay, object-oriented. Praboy says, why are you learning C? Why not some other language? Just curious. Oh, yeah, we've talked about this before. So the reason why we're learning C is because... Where is it? So cybersecurity... Because of cybersecurity CTF exercises. So there are two major categories which can benefit from knowing C. So that's binary exploitation. And a lot of beginner-level binary exploitation challenges are all about taking advantage of insecurely written C code, or binaries that were compiled using insecurely written C code. So that's for binary exploitation. Also, more importantly, reverse engineering. And Carla Silvar has subscribed on YouTube, thank you. But reverse engineering tools, they decompile programs into pseudo C code. So when the decompiler tool decompiles the program instructions, it renders them as pseudo C code. So if you can understand C, it's a lot easier to understand what the program's trying to do when you're reverse engineering it. Okay, so let's see. Sylveon says, what's your take on the moral of the story? The moral of the... You mean the Darknet Diary story? I guess we could talk a little bit about that, sure. The Darknet Diary story. So, system engineer tries to extort his company out of $2 million. Gets caught because his OPSEC was bad. Gets caught because his OPSEC was bad. Yeah, he was making $250K a year, but thought he deserved more. Was jealous of his boss, who was a billionaire. So I'm not too sure. I mean, the name of the person in the story, what was it? Nicholas Sharp? Nicholas Sharp is the subject of the story. And I wonder how much time he got thrown in prison for because of this story. Let's go ahead and just ask really quick. How long is Nicholas Sharp's prison sentence? A modern-day Icarus flew 2 years. Whoa, 6 years in prison. Only 6 years, huh? I mean, this happened. This happened in like 2021. Sentence date 2020. So he's actually getting out of prison in like 3 years. So will be out of prison in 2029. I mean, good luck to the guy. Fed time? Well, I don't know. It's an interesting story, because if you're making that much money, why would you decide? Well, okay. The other part of the story was, you know, he thought he was being ignored. He thought he was being ignored when he pointed out the security flaws and bad practices of his company. So this was a guy that kind of like went rogue. What OS are you on? This is Kali Linux that I'm using right now. Okay, if it's federal, they don't get good behavior release. Oh, I mean, I'm not really sure. I'm not too sure about what kind of sentence he got. Additional penalties, ordered to pay 1.6 million restitution. I mean, the other thing about this guy is, because he caused so much bad press for his company lost several $1 million in stock, in like in the evaluation, because he made a big stink out of like pretending to be a hacker who was. Well, no, he wasn't pretending to be a hacker. He was pretending to be a hacker. He was pretending to be a hacker who was extorting the company, and he wanted his company to pay him in Bitcoin, like $2 million in Bitcoin. Zammer says, that should make for some fun interviews. Hey, can you explain this gap in your resume? Yeah, that's when I was in prison. Oh, what did you go to prison for? Extorting my last employer. Yay. You're full on cybersecurity. I'm going to go to Fedora when I upgrade my rig. Yeah, I hear a lot of good things about Fedora, and like, you know, Red Hat Linux, all that good stuff. But yeah, this is primarily like a cybersecurity channel. Okay, let's continue learning about pointers. Sylvian says, recognition is a big workplace motivator. He got the opposite. Could have been a trigger. I mean, maybe. The thing is that he was already in a very privileged position, because he was making like a lot of money. He was making a lot of money every year, but I mean, it doesn't matter how much money you make every year. You always think that, you know, you could get more. And I guess he was also being ignored when he was trying to implement changes at his company. So he decided to go, what is the word? To go rogue. Truther Didon says, you ever do bug bounty? I've been poking at that lately. No, I've never really explored bug bounty, because bug bounty, I'm not good enough to do bug bounty. You need to be good, otherwise you could spend months and months without getting anything. And depending on how much time you're spending on doing your bug bounty, that could be really wasted time. Okay, let's go back. So long variables, I mean to make one then. So long variable. So X number of bytes for long variables. Okay, haven't cashed out yet, but I have my CWES. CWES, that's an OffSec. That's an OffSec certification, right? CWES. CWES. Oh, it's a Hack the Box one. Certified HTB, Certified Web Exploitation Specialist. Oh, awesome, awesome. Yeah, I've heard a lot of good things about the Hack the Box certifications. I mean, another really big certification if you want to do bug bounty stuff. Probably the Portswigger one. So let's see. So Portswigger, it's called the Burp Suite Certified Practitioner. Yeah, Burp Suite Certified Practitioner certification. BSCP, yeah. Brunoa, hello, nice to see you here. How long have you been doing this for? And if you wanted to change something that you regret, what would it be? Relevant to coding, of course. Well, not getting into tech and cybersecurity earlier would be my regret. It was called Certified Bug Bounty Hunter, and they renamed it after a couple of months. I guess they didn't want to make it bug bounty specific because it was web app stuff, and it was more applicable to just web app stuff in general. Oh, Gis, thank you very much for subscribing on YouTube. Thank you. Okay, let's go back to writing our really long program. So long variable, long longs. Long longs and long variables. So I guess we'll call this the long var. And we'll define it up here. Okay, Truther.on says, I want the OSCP or the next, I want OSCP next or the CPTS. I heard the CPTS is harder and the OSCP is more heard of. Yeah, I mean, if we're talking about cybersecurity certs, the OSCP is the most HR friendly. So that means that it's going to get you the most interviews. Will unlock the most interviews. But if we're talking about stuff that is more important for the skills that they teach, the CPTS. I mean, I haven't done the CPTS course before, but CPTS is considered more practical and teaches better skills. But it's not as widely recognized. I'm doing the mods, the modules for the CPTS right now. That's awesome, Truther Dawn. Okay, so long variable, let's define it up here. Long var. Okay, let's see. Truther says, I've compared the environment for both, and I might just do the CPTS. So this OSCP is proctored, actually. Yeah, the OSCP is proctored because they want to make sure that you're not cheating. So they're going to be watching you on webcam the entire time that you're doing it. I mean, I'm not really too sure about the environment for the CPTS because you've got like a week. You've got, what is the exam period, right? CPTS exam duration. Gives you 10 days in total to complete the practical enterprise network assessment, capture the flags, and compile your professional pen testing report. So a lot of people are really praising the CPTS certification because it gives you a much more reasonable amount of time to do it. It's also considered more difficult than the OSCP, so you gotta take that into account as well. But you also get time to write your pen testing report. You can spend like a couple of days doing it. So practically, you could pen test the environment in CPTS for 7 days and then spend 3 days writing your report. OSCP is 48 hours. Is it 48? I thought it was 24 hours. So is it 48 hours? OSCP exam duration. Yeah, 24 hours. So I've done the OSCP exam before, and I remember not sleeping. Or actually, I did sleep. I didn't sleep for very long. So maybe a few hours of sleep, and then back to testing. This was back in like 2021. I didn't pass the exam, but I did the course. Isn't there like 10 flags in OSCP or CPTS? So when I did the OSCP exam, it was a different thing. So let's see. OSCP exam structure. This was back from 2021, so it's probably changed now. So there was like it's like 4 total boxes. 4 total exam machines, and one of them was like a 60-point machine. Don't quote me on any of these values. Values. So 60-point machine, and there was like there were 2 like 25-point machines. And the goal of the exercise was to get something in the neighborhoods of like 200 points. And there was also like a buffer overflow machine, so BOF machine, which got you like 20 points. The structure of the exam is completely different now. So the current structure, modern structure of OSCP, so it's mostly, the majority of it is like Windows Active Directory. So what the goal is basically get domain controller compromise. That's the main focus of the OSCP now. And there's also like a couple of random machines, which might be Linux machines or they might be Windows machines. Okay, so let's see. I used all 7 days on the CWES, and it was like 10 flags, 5 panels and 5 system flags. I mean, I have no idea what the web app exam would be like for the Hack the Box one, but yeah, that sounds plausible. That sounds realistic. Okay, so long variables, floats and float variables. I mean, in what circumstance do the float variables, in what circumstances do these variables change from just the size of the regular data types? Truther says I made like a 50-page report for that. It's so low level for how hard it was. So low level for how hard it was? You're talking about like Well, I mean, if you take a look at the, you're talking about the web exploitation certification, right? So the Portswigger exam for the Burp Suite Certified Professional, I think they give you like 3, or is it like 5 different applications that you have to take over, and they're all based on labs that you already see on Portswigger, but they're random ones. So you might get like really obscure vulnerabilities, like, I don't know. Oh, what's a really obscure vulnerability? So something like insecure. What's the name of that vulnerability where you're decompressing objects? Deserialization. So you might get like a deserialization one, or you might get like a HTTP header one, or like request forgery. XSS. Well, I mean, cross-site scripting is your bread and butter, right? Okay, so let's see. Long variables, float variables, and then we got double variables, double and double variables. Okay, so the variable sizes never change from the size of the data type. So this exercise is a lot of code to establish little. I mean, I guess you do what the thing asks you to do. Double var. It does seem kind of redundant, yeah. Okay. But you've got some different stuff down here. So after the double variables, 4 bytes for pointers, 4 bytes for pointer variables. So we need to figure out how to make a pointer variable. Size of int this. So I guess we'll call it ptr var. The turnip, hello, nice to see you here. Pointer variables. Whoops. PTR var. So this is going to be now, how do we declare this type? So it's an integer, right? Integer, I think that's how you declare it. How is C going? Well, I mean, C is C. It's got all sorts of wacky fun features. Let's see. 4 bytes for pointer variables. 4 bytes for the address of the character variable. Oh, okay, okay. Where are the character variables? So number of bytes for address of character variable. So this is going to be the size of the reference for the character variable, right? Like this. Okay, int star is fine. You can declare it as void printer variable. That's the closest to a pure pointer variable, but you haven't learned that yet. So integer should be fine. Okay. Size of reference to character variable. For the pointer. So is this the address? So one is the address and one is the actual pointer. So I guess the actual pointer is the dereference? Or do I have it backwards? I think they mean size of and character variable. Pointer. So one of these is going to be the reference, and the other one is going to be the dereference. And the last one is going to be 1 byte for the value stored by pointer to the character variable. I think this is where I'm going to get tripped up. Okay, for the address of versus the size of pointer character variable, where character pointer character variable. Byte for value stored by pointer to character variable. Pointer character variable. So we have to make another one. So pointer variable, we need to make a pointer. So integer pointer character variable equals something, the reference of character variable, something like this. Pointer to the character variable is wrong. So how do we declare this thing again? So making a pointer p character var. But we want to, okay, we also need to put a semicolon here. Well, we'll figure out we'll figure out if any of this is correct when we try to run the program. It looks like the program execution is stuck. Okay, so why did it take so long to come back to us? So cannot convert character to int initialization. So this is line 13. So what is this supposed to be? It should be character. Oh, okay. So this should be character, pointer character variable, like this. What else do we have? We've got line 26. Float variable is not declared. Did we not make a float variable? I guess we didn't. So float var, and then line 30. So what's going on in line 30, which is line 31 now? Ah, okay. We got an extra. We got some extra parentheses floating around, which is no good. Okay, character something something. Hold on. We've got lines 33. Size of invalid type argument of unary. Okay, I think we've solved most of these, but we'll see what still comes up. So we got line 52, no, 28. Expected before the token. So what's wrong with size of double? Bytes for doubles, size of double. And we'll put another 60 minutes on the clock, and we'll see where we're at after 60 minutes. This is some deep study time that we're doing over here. The printf needs another. Ah, right. So size of double needs another parentheses. Okay, and then 30, same thing for 30. Yeah, same thing for 30. Okay, where are you learning the C, where are you learning it from? So it's a website called edub.org, and this is the link for the course over here. So it's a really nice course, especially considering it's free. And what I really like to do is I like to locate free resources for people who are learning tech stuff. So they've got like a C programming course for free. They also have like a very nice Python one for people who are getting into programming. And I suggest that for people who are getting into cybersecurity, Python's probably going to benefit you in most of your job roles. So I usually suggest people to learn Python as their first programming language when they're getting into cyber. So that's 28, that's 30, 31. Same thing, I guess. Okay, yeah, same thing. 32. I've forgotten to do this for all these. 33, 34. What's going on with 34? Ah. Alright, so now I've corrected all those. We'll try again. Still getting errors, okay, so line 33. Invalid type argument of unary. So this is line 33. Size of. So let's see. Proboy says, I learned Java as my first because I want something harder than Python. I'm glad I did. Now C and C++ won't be as hard for me to grasp. Yeah, I mean Java. The thing about Java is that there's a lot of boilerplate code that you have to write for basically anything in Java. I started learning a bit of Java last year, and it certainly has a reputation for being kind of verbose. And I guess The Microsoft version of Java, which is C#, is also kind of similar in that regard. So what's wrong here? So line 33, invalid type argument of unary character. So character variable. We created this, right? We created a character variable? Just checking. Yeah, we made a character variable. And this is line, which one? Line 33. You're dereferencing a character variable. So we're dereferencing the character variable. Does this mean we need to... We're trying to do the pointer for the character variable over here. Let's see. Newer Java versions try and fix that, but it's very new. I'm not... a lot of Java code is written in the older versions. I mean, Java is a very old language, and it was very, very popular for a long time. Yeah. It should be character pointer variable. Character pointer variable. So size of character pointer variable. Okay, we'll try it again. Now we've got error on line 33. Character pointer variable was not declared in this scope. Did I not call it character pointer variable? Oh, pointer character variable. Sorry. So PTR, CAR, VAR. But we also have line 34. And I guess it's the same thing? Should be the pointer character variable. Okay, now we've got, well, we actually have the program running now. Okay, let's check the input here. So 1 byte for characters, 2 bytes for shorts, 4 bytes for ints, 8 bytes for longs, 4 bytes for floats, 8 bytes for doubles, 1 byte for a value stored by the pointer to the character variable. 1 byte for the pointer of the character variable. So this doesn't match up anymore. So 8 bytes for... It says 8 bytes for pointers. 8 bytes for pointer variables. I mean, should all be the same. I mean, I think what's important is that it's all the same size. Eight bytes for the address of the character variable. Okay. 4 bytes for the pointer to the character variable, which is not correct here. And then 1 byte for the value stored by the pointer to the character variable. So they're running on a 32-bit system, so 4 byte pointers, but that second to last one is an error. Yeah, the second last one over here. Okay, persona management. What are we talking about by Proud Boys? Is that like a political thing or something else? Okay, so this is the pointer to the character variable. So size of pointer character variable. Quasi-political. Quasi-political? I mean, I don't want anything to be super political in here. So let's see. This is a dereference of pointer character variable, but what it should be is just the pointer. For character variable. Pointer to character variable. So like PTR character variable like this. Okay, what is the ampersand and what's the asterisk? So when we're talking about, I'm trying to understand myself. C syntax. So the asterisk variable name. This references a pointer. And the ampersand sign is a reference to it's a reference to a pointer, or at least I think that's what it is. And Hisen Tutu, hello, nice to see you here. You need parentheses for the size of the data type. It's optional. You need the parentheses for the size of the data type. Okay, so the data type pointer. Oh, okay, but you're wait. Pro boy, are you a proud boy or are you just a pro boy? Let me know. Let me know. Okay. So if does it still give us an error? 8 bytes for the pointer of a character variable. Okay, so I think we're okay now. Okay, I think you need a asterisk to store a reference. You need an asterisk to store a reference. Okay, well we outputted the correct stuff. What do pointers and arrays have in common? Well, a lot. Let's start with an important definition. If you see the name of an array without the indices, then it's always a synonym of the pointer pointing to the first element in the array. How does this work? Let's take a look at the snippet below. Okay, so pro boy says I'm a pro boy, bro as in noob and pro. Yeah, let's not assume that people are supporting. Anyways. We're here for the tech, not for the politics, most of the time. Okay, so integer pointer PTR ARR3. So we declared a pointer to an integer, okay, and a three element array of type integer. So the integer array is declared here as well as a pointer. Zamri says, "I'm an amateur boy myself. I don't get paid for this." Many of the leaders, I mean, let's not have too much political discussion in here, but I don't know about about this political group that we're talking about. Okay, the two assignments that follow the declaration set PTR to the same value. In other words, the following comparison. So array, ARR, is equal to reference of ARR 0. So this is always true. I mean, I'm not going to assume that people... I'm not going to assume that people are, pointing to a specific political thing unless they say it out loud. Okay, pointer, PTR, in array 3. We've declared a pointer to the integer, okay, and a 3 array element type integer. So here's our code. I'm sorry, did you mean to type out the word oyster? Okay, so here's our code, integer ptr array 3, ptr equals reference of array element 0, ptr equals ARR. Okay, the figure below illustrates the effect of our assignment. So what's going on? So the pointer ptr points to array, so the array element 0. Okay, well, I mean, you can have any affiliation you want as long as you don't talk about it. As long as you're not talking about, this stuff in chat, it's fine. The arithmetic of pointers. Okay, so pointer arithmetic. So it's mostly just like iterating through pointers. We're iterating through the contents of pointers, right? The arithmetic of pointers is significantly different from the arithmetic of integers, as it's relatively reduced and allows the following operations only. So adding an integer value to a pointer giving a pointer ptr plus integer equals pointer. Feels like it's very odd syntax. I mean, it's a pretty... It might take some getting used to, yeah. Subtracting an integer value from a pointer giving a pointer. So pointer minus integer equals pointer. Subtracting a pointer from a pointer, giving an integer, pointer minus pointer equals integer. Comparing two pointers for equality or inequality. So this gives a value of type integer of either true or false. Pointer is equal to pointer is either going to result in true or false. Any other operations are either prohibited or meaningless, and only the ones mentioned above may be used. So let's discuss briefly what's happening to a pointer subjected to these operations. We'll do this by assuming the declarations and assignments shown in the editor. At this point, pointer 1 points to the first element of array. Okay, let's take a closer look. So there's a pointer called pointer 1. There's a pointer called pointer 2. There's an array, which is an integer array with 3 elements. And then there's an I integer. So pointer 1 equals array. So pointer 1 equals array means that it's a pointer that points to array element 0. Okay, hey, how is pointer minus pointer an integer? How is pointer minus pointer an integer? I mean, this is what they tell us. Subtracting a pointer from a pointer, giving an integer. So if we subtract two pointers, if you subtract two pointers, then the result is no longer a pointer, I guess. pointers are integer numbers. Pointers are integer numbers. So, I mean, the pointers are all memory addresses. It's the offset in bytes between the pointers. Oh, okay, okay. So if you subtract 2 pointers from each other, it's going to give you the difference. The difference in bytes, I guess, between the 2 pointers, because the pointers are our memory addresses, right? So let's think about this. So pointer math. So PTR minus PTR equals the offset between the 2 addresses. So let's pretend that we've got some pointers, and the pointers are 000. These are all hexadecimal values, right? So let's just say 16, and we got another pointer at 00032. So if we do the math, we subtract these. So the result is going to be hexadecimal. Well, it's not going to be hexadecimal 16 because that's decimal math. Actually, let's do this reversed. So hexadecimal 32. Let's just subtract something that that we can easily understand. So how about hex 8? So hex 32 minus hex 8 is going to be 0 and then 2f. So 2f minus 6. 2f minus 6 is going to be like hexadecimal. This is tough. It's like 2. Is it like 2.9 or 2.8? Wait. Persona management. I mean, all I know is that the Proud Boys are like a right-wing group. I don't know about their politics, but you're accusing me of being inauthentic by acting like I don't know who the Proud Boys are? Listen. Persona management. You're usually a good chatter. But why are you getting so political now? And accusing me of acting ignorant as to like what these political groups are, what these political groups are. I think you should reconsider. But yeah, I mean, we're talking about like offsets between like memory addresses here. Okay, move on to the next. So the arithmetic of pointers. After the following assignment, pointer 2 points to the first element of array 2, and the figure shows the current state of the variables. Okay, so pointer 2, after the following assignment, pointer 2 points to the first element of array. The figure shows the current state of the variables. So pointer 2 equals pointer 1. So pointer 2 and pointer 1 are the same. They point to the start of the array, I guess, and element 0. Okay, we can check if the two pointers are equal. Yes, they are, as they point to the same element of the array. Okay, Pucius Maximus says, in all fairness, unless someone is a genuine politico with a pulse on the internet history, they won't even know A, the context of most modern groups, or B, the how or even when it matters. I mean, listen. Don't tell me that everybody and his grandma knows about... Yeah, okay. Anyways, let's continue. So if PTR2 equals PTR1, let's make this a bit bigger. So if PTR2 equals PTR1, then do something? Let's check how the addition works. These statements do the same operation. They add 1. These statements do the same operation. They add 1 to PTR2. Oh, it's time. Yeah, it is bird time. Okay. Alright, let's put on the birds. Alright, we'll be back in about 50 seconds. Just need to take a little water break, but enjoy the birds and the music. Okay, so the turnip asks, I have a question that's somewhat related to birds. Have you played Wingspan? Squirrel. Yeah, there was a squirrel. Wingspan. Yeah, I've played the board game Wingspan before. It's pretty fun. It's got a bunch of birds and stuff, and you can learn about new birds by playing the game. Okay, so these statements do the same operation. They add 1 to PTR2. They add 1 to PTR2. We can interpret this operation as follows. So it is taken into account what type is pointed to by the pointer. In our case, it's an integer. It is determined how many bytes of memory the type occupies. The size of operator is used automatically for that purpose. In our case, it's size of integer. The value that we want to add to the pointer is multiplied by the given size. The address which is stored by the pointer is increased by the resulting product. In effect, the pointer moves itself to the next integer value in the memory. The effect of this incrementation is shown in the figure below. So PTR2 equals PTR2 plus 1. okay, or PTR2 increments. So PTR1 points to array element 0, and PTR2 points to array element 1. Okay, what would happen if we added 2 instead of 1? So in this case, PTR2 would be increased by 2 times size of integer, and thus PTR2 would move through 2 integer values and would point to the third array of the third element of the array, namely array element 2. The comparison PTR1 is equal to PTR2 is obviously false, while this one, PTR1 is not equal to PTR2, is true, as the addresses of the pointers point to different memory locations. Okay? So let's subtract the pointers in the following way. We said earlier that subtraction gives the result of type integer. How is it calculated? Taking into account the type to which the pointers point, integer, okay? This means that both pointers need to point to the same type. The compiler will check it. The addresses stored in the pointers are subtracted. The result of the subtraction is divided by the size of the type pointed to by the pointers. The final result tells us how many variables of a given type, that is integer, fit between the addresses stored in the pointers. In our case, it's obviously 1, and this value will be assigned to the I variable. So I equals pointer2 minus pointer1. The result will be greater than 0 if pointer2 points to the memory located after pointer1. Otherwise, it will be less than 0. Try to guess the result of the following operation. Pointer1 equals pointer1 plus 2. So pointer1 equals pointer1 plus 2. So if pointer1 points at element 0, if we add 2 to it, that means that pointer1 now points at array element 2. Because we move from array element 0 to array element 1 and then array element 2. So pointer 1 now points at array element 2. Okay, good. Okay, let's assume that the following operation has been performed. Can you guess the effect? Pointer 2 equals pointer 2 minus 1. So it's going to point at the previous element. So now pointer 2 points at array element 0, whereas previously it pointed at array element 1. Okay, just be aware this works correctly with typed pointers. I mean, are there untyped pointers? Santa Sis, hello, nice to see you here. What is up? Okay. Here's what I get. What do you get? Void pointers are a thing. Ah. Okay. Try to determine the result of the following subtraction. So pointer 1 minus pointer 2. Is it 2? Yes, it is. Congratulations. Hold on. So pointer 1 minus pointer 2. So pointer 1 is array 2. And pointer 1, so pointer 2 is array 2. Pointer 2 is array 0. So if you subtract array 0 from array 1, array 2, we get array 1. But the difference between these two is 2, because that's the difference between their locations. Okay, so familiarize the student with fixing errors in the program, integer numbers, printing on screen. So check the program in the editor. It copies values from one array to another, adding 1.0. Okay. ProBoy says x equals variable. Okay, and dereference of x equals address of x. Reference of x is address of x, okay, and asterisk variable is sort of like telling the compiler, go to this address and look at the value. Yeah, I think that's how it is, right? So let's say that integer x equals 1. Just, just for fun, x equals 1. But reference of x equals the memory address where x is stored. And what was it? So dereference of x is the value, look at the memory address of x and return the value. Or at least that's what I think it is. So let's see. SysOS says ampersand references the address, okay? And the asterisk dereferences the address. They change what gets put into the retrieval operation. So in concept correct, in details almost correct. I mean, I'm sure the details are going to come back to haunt me later. What's reference and dereference? So reference, as far as I know, reference is basically the memory address. So reference is the memory address. And dereference is look at the memory address and get the value. Okay. So it copies values from one array to another, adding 1.0. Then it's supposed to print the numbers from the middle point of the new arrays to both ends. From the middle point of the new array to both ends alternatively. Warning, the midpoint is between two cells, one before and one after, start with them. We'll use pointers to make a copy in order to show you this kind of operation. But in this case, you can use array indexing. Find all possible compilation errors and logic errors, fix them. Your version of the program must print the same results as the expected output. Before you use the compiler, try to find the errors only by manual code analysis. So expected output is going to be a bunch of floating point numbers. Okay, it's basically what you said. Reference equals the address of the thing, and dereference is look at the value. SysOS Master says reference equals retrieve the memory address. Dereference means retrieve what's at this address. There are others, they're each other's inverse operations. So star ampersand I is the same as just using I. Star ampersand I is the same as using I. Okay, so our expected output is this. What happens if we just run the program? Probably a bunch of errors. Okay, let's fix these errors one at a time. So we start with 17. ISO C forbids nested functions. Forbids nested functions. So this is line 17. This is the 70s. I hadn't figured out good syntax yet. I mean, Okay, pointer bigger, start, equal bigger numbers. What? Oh, okay. So they want this to be, this is just a bigger numbers. So bigger start equals bigger numbers. I think that's what we're supposed to be doing, right? So bigger numbers is an array, a float array with 10 elements. So bigger start, float bigger start equals bigger numbers. So because it's a pointer, the pointer points to the start of the array, bigger numbers, right? Also, from the perspective of assembly, it makes perfect sense. All right, so we also have, this is still line 17. So line 17, okay, we'll reset this, we'll run it again. All right, so stuff is coming back to us. We also have a segmentation fault. Wait, why does the program crash? Okay, it copies values from one array to another, adding 1.0. Then it's supposed to print the numbers from the middle point of the new array to both ends alternatively. Okay, let's try to understand the program here. So we've got an integer I, then float numbers. So the numbers are a float array of 10 elements. I'm going to just trust that this is 10 numbers. Then we've got a float bigger numbers. Float bigger numbers is also an array with 10 elements. And then we got some pointers. So pointer source is the numbers array. So source is numbers array element 0. And then the copy pointer is pointing to bigger numbers. And then we got a little for loop. For I equals 0, I is less than 10, I increments. Copy pointer equals source pointer. Copy pointer equals source pointer. Then copy decrements. So this is so when you decrement a pointer, it points to decrement copy, but increment source. Okay, the turnip says, are you trying to write or read out of the array? Well, the program is supposed to be doing use pointers to make a copy in order to show copies values from one array to another, adding 1.0. Then it's supposed to print the numbers from the middle point of the new array. I mean, this is... Let me try to understand what exactly we're supposed to do with this program. Decrementing from the first element of the array seems bad. Okay, check the program in the editor. I just want to understand what the program's supposed to do. Are segmentation faults always memory issues? Segmentation faults are usually when the program tries to access a memory location that doesn't have any instructions, or it has like unexpected instructions, or at least that's how I understand it. So check the program. It copies values from one array to another, adding 1. Then it's supposed to print the numbers from the middle point of the new array to both ends. So let's try to understand this. Copy a value from one array to another array. Then add 1.0 to the value. Okay, Turnip says, generally a segmentation fault happens when you read or write to memory that's not your own, or at least that's how my understanding is. So Anarchist says that they are memory mapping faults. You attempted to access a memory address for which no segment was mapped. Remember, the memory addresses you use in a program aren't physical memory addresses, they are virtual memory addresses. So copy a value from one array to another array, then add +1 to the value. Alright, so let's think about this. So if we've got like array 1, and let's just say array 1 has, let's say array 1 has like 0, 1, 2 in it, and we've got array 2, which has 3, 4, 5. So we want the program to copy a value from one to another. So array element 0, which is, I don't know, denoted by this, is copied to, so array 1, 0 is copied to array 2. If it's copied over, does it get copied over to like element 3 maybe? Because this is element 0, 1, and 2. Then 1 is added to the value. So does that mean that after this operation, array 2 is now 3, 4, 5, and 1? No idea. Okay, so ProBoy says integer pointer p and p are different. One means p is the address of the integer, and the other one is dereferencing. Am I right? No, I mean, I guess it really depends on where in the program you are. I guess the first one, yeah, it can be interpreted as like the creation of a pointer, and then the second one is dereferencing the pointer. Okay, Anarchist says you have to map segments of physical memory into the virtual addresses before use. Zammer says that the intent is bigger numbers I equals array I plus 1, I think. Let's take a look at the program. Okay, so we got source. Source is numbers, so numbers is so this is numbers array element 0. And copy is bigger numbers, so bigger numbers array element 0. Okay, and then we do 10 times. We're doing something 10 times with the for loop here. So in every iteration of the loop, dereference of copy equals dereference of source. Dereference of copy, which is looking at the value of copy, is going to be the value of source. So dereference of copy is the dereference of source. So these are just going to be values. So copy and source just point to different different elements in the array. So it's basically getting the values of the arrays, the array numbers and the array bigger numbers. Then copy decrements and source increments. Okay, Zammer says, take the value from the location pointed at by the source and put it in the location indicated by copy. Okay, and we've got float copy, float bigger end equals copy. So this is after the big for loop happens over here. So float bigger end equals copy, bigger start. So these are pointers here, bigger end and bigger start. So one points to copy and one points to bigger numbers. And then we got the middle of these new arrays. So middle 1 and middle 2. So bigger numbers, middle, and then middle 1, middle. And then we run another for loop, which prints out all these numbers. For something, middle 1 increments and middle 2 increments. Middle 1 is greater than or equal to bigger start. So what is the so because we don't have a value that is being iterated over in the first part of the for loop, what's happening here? What are the implications of this? So in this loop, middle 1 and middle 2 increment each time the loop runs. But I'm guessing that this is going to be some sort of This is some sort of infinite loop. Which is why the program crashes. And each time we run the loop, we're going to print off middle 1 and middle 2. So what happened here? So it basically went on... Whoa. So the program that ran, it printed off middle 1 and middle 2, which are all like 0 values. And then when we got to probably like a value that doesn't have, that's not defined, it spat out this really, really big number. And then when it arrives at more of these undefined values, it spits out these even bigger numbers. And then it just runs like this for a while, until ultimately the program just crashes. We have some runaway pointers here. Looks like it. Okay, we got an ad running on Twitch right now. Okay, let's put on my favorite video. So these are our fledgling Stellar Jays. And these guys are probably just a couple of weeks old, and they're just having a little bath and a little drink of water. We'll be back in about 60 seconds. Okay, they live for 1-digit number of years. I mean, most of them do. But birds, I mean, they're born completely helpless, you know, without feathers and all that stuff. Let me look up really quick. So, how long does it take a Stellar's jay to fledge? Okay, Stellar Jay's nestlings leave the nest to fledge after 16 to 18 days after hatching. Right. Okay, so it's a little longer than I expected. So it's closer to 3 weeks. They make short hops and low flights right after leaving, achieve strong sustained flight by 30 days old, and depend on their parents for food for about 1 month post-fledging. Oh, okay, okay. So even though they're out of the nest, they still need to be fed by their parents for 30 days. Huh. That's funny. Alright, so something's going wrong in the pointer math over here, right? Okay, so we're copying over. Copy equals source. Copy equals source, then copy decrements and source increments. So, I mean, I'm guessing that part of the problem is in here. So copy points to source points to numbers, and copy points to bigger numbers. The other thing that we need to do is we need to insert the larger numbers in there, right? Okay. I had a chicken, it died in a few months. Got a flu. She's mothered many chicks. Oh, okay. Ah, all right. I mean, I've heard of people owning chickens, and it's probably a very good source of like eggs and stuff like that. Sounds like a good idea, but you need to properly take care of your chicken. Otherwise, it's going to be living in a very dirty environment. So numbers is just a bunch of numbers. Bigger numbers should be each one of the numbers that is copied over plus 1. The expected output over here is like 4.5. So 4.5, I'm guessing that one of these numbers is going to be 3.5. Hold on, let's take a look. Uh-oh, did I? I'm not, 4.5, 6.8. Oh, okay. Wait, what did they say about, like, adding 1? It copies values from one array to another, adding 1.0. Then it's supposed to print the numbers from the middle point of the new arrays to both ends alternatively. Okay. Unfortunately, we've kind of run out of time here. Let's see. That's why we moved the living one to the livestock farm. Okay. But yeah, I don't want to go too late, so I guess we'll call it here. I think I'm gonna have to spend a good amount of time trying to understand this problem because it's not immediately coming to me. And I want chickens. Well, I mean, it'd be nice to have chickens. Not every place in the world is gonna let you keep them, especially in an urban environment. Anyways, so today was Co-working Tuesday, and we spent 3 hours taking a look at C programming language and, discussing the finer parts of the funny syntax and pointers and all that great stuff. Tomorrow, we're going to be doing some different stuff. So tomorrow, we're going to be taking a look at binary hacking, and we're going to start a new little course over at HackerFrogs called Binary Exploitation. So we're going to be talking about very, very basic binary exploitation attacks. We're going to be taking a look at the demonstration for the Try Hack Me Hacker Holidays, and we're going to be playing a puzzle game called Database Detective. So Database Detective is going to be, it's a game that requires you to use SQL language or like database lookup language to solve some crimes. So we're going to be trying that out, and we're going to be taking a look at some new challenges over at HackerPoll for binary exploitation. Binary exploitation attacks in Hacker Holiday. Yeah, when are we streaming next? So the next one is going to be tomorrow, but it's going to be at a different time. So we're going to be streaming how many hours before? So 6 hours before today's start. We're going to be going from 2 p.m. PST until 8 p.m. PST. And yeah, look forward to that. Okay, so we'll be back tomorrow, but in the meantime, we might want to find some people who are streaming InfoSec. So basically cybersecurity and other. I think the InfoSec streams website here is broken, because it doesn't seem to show anybody online anymore. Let me take a look at Twitch and see who else is streaming right now. Your Cyber Doctor is on, is he? Let me double check that. So your Cyber Doctor is on, okay. Yeah, I see it. Well, let's go ahead and raid into his channel. So it's, so your Cyber Doctor is someone who works at a cybersecurity accounting agency, I think? Or he works as an accountant for, he usually ends around now. Let's take a look at what your Cyber Doctor is up to right now. Okay, Nullsec says, what lesson did you finish on? I'd like to catch up before the next C stream. So we're currently doing pointers. You'll know it when you see it when they start talking about pointers. Okay, so mastering the core of LLMs, AI Journey Day 178. 178, geez. Okay, let's start the raid. Okay, and when you arrive over at that channel, if you give this message over here, OSFrog, hip hop hack, OSFrog, I would really appreciate it. Alright everybody, we'll be back tomorrow, hope to see you then, but until then, HackerFrogs out in 5, 4, 3, 2, 1. See you next time everybody.